IPv4. This is my third lecture in networking. We are about to cover the logical addresses. As you know, the logical addresses is what we so far know as IP address. So what is an IP address? Is Internet Protocol address, or sometimes we call logical address. As we have finished the physical address or MAC address last lecture, today you should know that IP address is divided into two versions. We have IP version 4, as it's clear here, it's 32 bits, and we have IP version 6, which is 126 bits. As you know that IP address exists in the network layer. So we have physical data link, then network layer. In network layer, as we have mentioned before, that data are in packets. So from the source, from the host to destination, the data delivered in packets. Who is responsible about IP address? An organization called Internet Assigned Number Authority, which is IANA. And it is necessary to know that in IP version 4, since it's 32 bits, we have a problem we call address depletion. That means number of addresses we have now is limited to 2 to the power n. That means 2 to the power of 32, we have only 4 billion users, and on earth we have more than 7 billion population, and number of users are extended and increased from year to year. That means IP version 4, which is contains of 32 bits, is not willing to be able to accommodate all users within the next 4 to 5 years. Accordingly, we move to IP version 6. But before explaining IP version 4, you should know that even if we are moving to IP version 6, IP version 4 will exist and still be able to be used. There are other services like tunneling. It will allow you to use both IPs at the same time. So there are two private notations to show IP version 4 address. Number 1, by primary notation. Number 2, dotted decimal notation. That means, as we have explained before, IP version 4 contains of 4 sections. Each section contains of 4 digits. These digits are octets, which is 8 base. That means the number started from 0 and at 256. If we convert this number to binary, that means you start at 8 zeros. You see there are 8 digits, ended at 111. That means the first letter, if it was 0 0 0 0, these are 4 5 6 7 8 dot 0 0 0 8 zeros. Okay, so the last number, it should be 81 in every location. That means the last number is going to be 11. So this will be the last address. So the first address starts from 0 0 0 0. Last address will be 8 ones, or 256 256 256 256. This should be understandable. So let we have an example of IP version 4. For example, this is a decimal number. This is a binary number. If we convert it to decimal, we can use a calculator if you like. Okay, but you should be able to calculate it by yourself. So we have a decimal. What is the number? 128 11. So 128, we convert it to binary. This is the result. This is the 128, which is should be binary. Let we go to decimal. 128. I convert it to binary. This is the result. It's 1 and we have 7 zeros, which is same like this number. If we convert 11, we're gonna have, go to decimal, 11, go to binary, it's 1011. Okay, the rest you fill it with a 0 because 0 at the left hand is not counted, and so on. So you have two options, either to represent your IP version 4 in binary or in decimal. But you should know that every number has 8 octets. So if you have 2 to the power of 8, that means every location is limited to 255 only. Why? Because you start counted from 0, and by adding 256 minus 1, because you start from 0, the result is 255 address. So if I give you an example that convert these two addresses into decimal, you should be able to convert them by using calculator or normal calculation, as we studied in grade 1 in logic, by converting number from binary to decimal and from decimal to binary as well. These are decimal number systems. You can solve it by converting it to binary, as we have covered earlier. So this is an example that find the error. As you can see here, the number is 111, 56, 045 and 70. What is the error? What's wrong in this number? The 0 on the left side in decimal representation numbers should not be mentioned. So the mistake in here is this 0. It should be deleted. The next number is 221, 34, 5, 7, 8, 20. There are 5 locations. It's impossible. That means the mistake in here, you should have only 4 locations, 4 packets to put your digits inside. In C, we have 75, 45, 301, and 14. Obviously, the 301 is more than 255. That means it's impossible to have such a number. So this is the mistake in this address. Here you have a combination of binary and decimal. Obviously, we cannot have binary and decimal in the same IP address. It should be in one numbering system. Classification of IP version 4. As we have said that IP version 4 started from 0, ended at 255. So as we have 256, we have classified these addresses into 5 classifications. We have class A, B, C, D, and E. So class A from 0 to 127 is fixed. So if the address is between 0 and 127, so that means it's class A network. This network is very huge network. Why? Because we have 3 locations. We can put users up to 2 to the power of 24 users. That means a huge number of users can be accommodated inside this network. That means this class can be used by countries or a huge organization like Microsoft and Cisco. Class B, here the first section and second section are fixed, the yellow color. How do we know that this address is class A or B? If the number started from 128, ended at 191, that means this number or this address is within class B. That means we can control the first and second location only. The yellow locations are fixed. Class C is the smallest groups given for small companies. Class C can have users from 0 to 255 users. Class D and E is unusable by normal users. Why? Class D is for special applications like NAT and so on. Class E is for future research. These numbers, students, you should know that it has a binary representation, which is easier to know. So in binary, if numbers start from 0, so class A, 10 is class B. If class C, so 110, 1110 class D, and class E is 4 ones, quadratic ones. So that means Normally in every exam I ask my students how to find the class of your network. So these numbers and these tables should be memorized. Thank you very much. This is the end of part 1.